So I went underneath my 1990 K1500 to check the transmission, the transfer case fluid, because my four-wheel drive is making some noise, and I saw this little gem under here. It supports the rear end of the transmission and the transfer case, and it looks horrible. There's like a hole right through this body member here. The giveaway that there was something that really needs to be done here is that this member I would expect to be completely flat across the bottom of the truck, and you can see there's a little bit of a bow here now because this is actually so weak it's actually starting to fall with the weight of the transfer case on there. So we're going to take it off and see if we can repair this. I looked online, I found some not very good condition used ones. They were also very rusty, and they're selling for, I don't know, over 200 bucks. So it didn't seem like trying to replace it with another one was really going to be effective. I tried to get a replacement. Doesn't look like anybody makes them. Discontinued. So I'm going to repair, I think. So conveniently, the only thing that are holding it in is 2 bolts on this side and 2 bolts on the other side. I use a air chisel at low pressure in order to take off some of the rust scale that's been building up on the side of the frame, and you can tell here there's a lot coming off. So this is the passenger side of the transmission mount, and you can see it's in really poor condition. There's 4 bolts, 2 on each side, that hold it in. I think it's a 18 millimeter and a 17 millimeter on one side, but I used 18 millimeters on some of them, so it may just because it was rusted. So 17 or 18 millimeters. The skid plate was held on with these Torx screws, Torx bolts, and that was a T50 size bolt. And then, oh yeah, the nut on this guy was 15 millimeter, which also were in really bad condition. This is the first time I've had the opportunity to use one of these bits here. And I used it to take out this nut because it was so rounded off, I couldn't get it out. So those guys here are impact bolt and nut mover set, REXBETI, and you can pick this right up on Amazon. I'll make a link. But I usually don't have a lot of luck with these types of things, but it worked out here, so I'm just going to go with it. So here I'm actually drawing a line about where the metal is really weak and where I want to replace it. And I actually made a mistake here when I grabbed some metal. I grabbed the 16-inch piece of metal, and if you look at the measurement I have here, it's closer to 17 is what I needed. So it caused me some extra work by, you know, missing the mark a little bit on the piece of metal that I was going to replace this. You can see how weak the structural member is here because I need to flatten it out to draw the template, and I just put a little weight on this thing, and I was able to bend it back into shape. I'm using 1/8 inch mild steel here, which looks like it's about the same size as the original part, although in most places here you can see it's much thinner. Also, if I slide down to this end, you can see what that side was originally supposed to look like. So all I have to cut this is a jigsaw. So I'm going to try to minimize the amount of cuts I have to make. It's only an 1/8 inch plate, but generally, you know, if we can get away with less cuts, it'd probably be better. So I started lining this up along this edge, so I'd have to cut less here. But I noticed that this part here that starts pretty wide and kind of next down here looks very much like this profile here. So I was thinking that I could save myself a cut by taking this remainder piece and like using that over here. So it's kind of like a puzzle you got to figure out, but you can probably save yourself a lot of time and a lot of cuts if you use pieces that you're cutting out and not have to reshape them or recut them in order to make them do what you want it to do. Yeah, so this is really like a, you know, measure twice, cut once scenario. The other thing that's important to keep in mind is that if it doesn't look exactly like this part, it really doesn't matter. The only thing that's super important about this particular design is that there's a torsion bar that sits here. So it has to be, this has to be very low. And then over here, this has to be at this height for the transmission. And this is, you know, molded to give that some strength. But then this is really low to clear this torsion bar. So as long as I can keep this at a low elevation, it really doesn't matter as much like what happens over here. So I might take a little bit of liberty in redesigning this part a little bit so that it's convenient to cut. I bought some new bimetallic blades to do this job, and although I started using the jigsaw with this, you know, cutting and tapping fluid, I eventually ended up swapping over to using a grinding wheel because the jigsawing was going very, very slow. So just to give you a comparison between how fast it is to use a grinding wheel, a cutoff wheel, versus using a jigsaw, I'm actually going to record how long it takes to do the jigsawing and how long it takes to do the grinding per inch, and we'll compare the results. So this cut here is a 16-inch cut, and it took me over 9 minutes. So it looks like I'm doing about 1 3/4 inches per minute using the metal blade and the jigsaw. The blade didn't seem to be getting dull, but the next cuts I made seemed to be going much, much slower than the earlier ones. And then eventually I got to a point where the jigsaw blade started popping out. You know, you think I would have given up earlier. I mean, it took me 8 failures before I gave up on the jigsaw. But there was something that I was doing wrong. There's a wheel right in back of the blade, and if you're not careful and it moves away from the blade a little bit, the blade won't sit square on the jaw and it'll pop out. Okay, so here I gave up and decided to go with the grinding wheel. Looks like on this first cut I did 10 inches in about 4 minutes, which would be 2.5 inches per minute, which is surprisingly not that much faster than a jigsaw. Still, it's easier, so I'm just going to use the grinder instead. So I'm just going to put the jigsaw away and grind the top plate. Okay, so this is super annoying. This grinder has a built-in circuit breaker, and if you put just a slightly too much pressure on this thing, the circuit breaker keeps on popping, and you gotta stop, reset the circuit breaker, and then it'll let you start back up like a second later. Okay, so 4 breaker pops in a minute, and I've completely had it. I'm taking this thing apart and removing the circuit breaker. You can check out this other video if you want to see the replacement of the circuit breaker. So this cut here, I measured at about 2 inches per minute. So again, it's not that much faster than the jigsaw. Okay, so I'm measuring here to make sure that I don't cut off too much or too little of the existing frame. So when I weld this on, it has to be exactly the right length so that I can get it back lined up with the bolt holes in the truck. So this top plate here kind of has a bend to it, kind of curves up like this. So this guy that I'm trying to replace this with is not really doing the job. So I'm draw some dots here. I'm going to try to bend this a little bit. This guy's a magnetic brake. I don't use it a ton. It takes up a ton of space. But when you need it, it's one of those things where it's like really nice to have. So I'm going to start welding up my first part here. I have my Miller welder up and humming. I have 30,000 ER70S welding wire. I'm using argon CO2 mix, and my handy dandy chart here tells me that if I'm working on 1/8 inch, I'm going to be setting that at, let's see if I can find it right over here, 17,305. So I set that pretty close, 17,302. So I'm going to start running a couple beads here and hopefully try to pull this thing together. I watched the video about welding MIG so that it looks like TIG, and I thought this was interesting, so I decided to try it here. I have this other video you can go check out if you want the details about welding MIG like TIG, but here I am trying to do some MIG welding so that it looks like TIG welding. Seems to me that the gauge that you can use to determine if like you're a good welder or not is like how many welds you look at where you go, and how many welds you look at and you go, And normally, like when you start, it's all like, and then as you get better and better, it's like half and half. And then when you know what the hell you're doing, it's like, you just go, all day. Well, I'm not to that point yet. I'm kind of at the, So, I don't know. I got some good ones. Got some ones. But, it'll work. So, here's the old one. Here's the new one. The game here is going to be trying to figure out how to connect it in with that one in a way that really, really connects the two halves together. So we don't have like a weak point. I think I might do some, I'll have to butt weld them and then maybe do like some lapping welds around to kind of strengthen up. Like put some extra pieces, some bars in here that kind of overlap both and maybe makes it a little strong in that area. So, on the back of this pellet bag I made in template, it kind of shows how the original part aligned before I cut it in half. So this is kind of important because without this, it'd be very, very difficult to try to realign this without putting it back in the truck. And there is a little bit of play here, so I guess it's not the end of the world if it doesn't line up perfectly. So earlier on I cut some, I don't know, 5/8 inch pieces out of the block because I knew that there was going to be little spaces here that are going to be left because this is not exactly the same height as this, and that was done intentionally just so I had less cuts to make. But I'll just pop a little piece of metal in here. You see this over here, it's like a little crack. But I'll just put some metal in here because I'm going to have to like strengthen this up anyway. So I'll use those pieces for that. Alright, so I guess we're done with this ridiculousness. So this guy has some weird thing going on here, but you know, I put that little plate in there. These swells don't look that bad. Yeah, maybe I do know what I'm doing. This part is hot. Oh, look at this side over here. Yep. Yeah. I was gonna do some, you know, put some metal in here, but it's not necessary. I mean, this thing is welded together every way from Friday. I got all sides. I got inside there. I got these welds here. I think I'm just gonna call this one a day. Walk away. Alright, here we go. So, I was so excited to finish this part, I actually forgot to do some more taping. So I ended up painting the entire thing with some spray paint, and I threw it back in the truck, put in some new bolts, and it actually, the holes lined up perfectly, and everything kind of went back together. I know it's a sad ending to the video, but the long story short is, completely half-assing it, completely whole worked. I was thinking of starting a new game, which is if after I do a job, if I have more than like, I don't know, 5 pounds of rust left on the floor after I'm done, then I'm just gonna get a new truck. So that's my crazy idea for the day. So I'm gonna like put this all in a bag because I literally want to know how much rust the truck left behind on this subframe job. I'm almost embarrassed to admit how not close I was estimating how much rust came off my truck. So I put it inside this bag here. All the stuff that was on the floor, which I just cleaned before I started and now just cleaned now. And it was 12 pounds. 12 pounds of rust that ended up inside this bag. But at least I'll be getting better mileage now.